Hey guys, hello. Hey guys, welcome back to new stream. Let me check. I'm audible. Okay, so what we gonna do today is that solving more problems on graph. So before solving any problem, so I'm thinking of doing a revision session. Means, before starting any stream, I will go through all the solution I have done for the topic like graph, trace, those who are doing that time. So what I'm gonna do is revise all the solution that I have done. Like these, first is number of provinces. So what this question is states that there are n cities. Some of them are connected while some are not. If city A is connected directly with city B, if city A is directly connected with city B, and city B is directly connected with city C, then city is connected directly with city C. Okay. Province is a group of directly or indirectly connected cities and no other cities outside of the group. Okay. You are given an n cross n matrix is connected where is connected I and j is equals to 1. If the ith city and the jth city are directly connected, then it is connected, otherwise not. Return we have to return the number of provinces, like how many connected graphs we have in all the examples. Like there is two connected graphs. First is 1 to 2 is connected with undirected graph, and 3 is not connected but it is a graph. So there are two uh, provinces in this graph. Similar to in this, there are 1 2 3 that are not connected to each other, but they are graphed separately. So there are three provinces. So what I have done in this problem is that I have used the traversal technique of anything like BFS means anyone, BFS or DFS. So what I have done is that I have created a visited array. So whenever I have to count the connected graph, means connected graph are those graphs that have different that are not connected to all these vertices in the graph. So that these are not connected to the 3, means 3 is separate from the 2. So we use a visited graph. through which we can this visited graph is that, like, if you have any, if you have vertices from starting 0, so then what you have done is that you have to count from start from 0 and 1 2 3 4 up to the wherever you have the nodes, like mostly you have the ninth. So we start from traversing the graph. So if we found any graph and we check the adjacent list or adjacent matrix, that we which tells us about the connection, means edges, in the graph. So okay, then if okay, so visited graph, what visited graph done is that if it completes the traversal of this graph, like you have traversed 1 and 2 in the graph, then if you look for the edges from 2, then you don't have any edges. Then what you're gonna do is that you have to check for the visited array, that all the vertices are visited or not. But if you found any, like 3 is not visited, then what you're gonna do is that you apply traversal technique, BFS or DFS, anyone, for 3, and then check for the then check for the other edges from the 3 and mark visited in the array. So 3 doesn't have anything. If it has any node connected to it, then we traverse them also. So what's the solution we have done is that okay, so this is the BFS solution we have done in that. So we have given the find circle num. This is the function we have given, and then this is the we have get the size of the 2D vector through which we are getting the vertices and edges. This is size, and we have created a visited array for the size n. That's how that's I told you. Then count, we initialize a count to count the provinces. We then I have run a loop from 1 to n, and the size of the matrix. Then if we check the visited array. If visited array has 1, means that no arrays are, no vertices are are visited. Definitely visited. Then what we're gonna do is that we increase the counter and then we visit that by using BFS technique. So we give the index and connected vertex matrix, then visited array. Then we for BFS what have done is that we initialize the queue. Every time we are using the BFS, we have to get the queue, then we push the index we push the index array in there, that we are starting from traversing, then visit, then that vertex that we are at, we are that position, then it will be visited, then we convert it to 1. Then from that point we are gonna traverse all the edges that are going through the index. While how we can do that, because we have pushed that value into the queue, then we are traverse from queue to queue, means we are gonna empty the queue one by one. So we are applying the condition while queue is empty. Until queue is not empty, then we are gonna traverse again and again. So we are taking an element, then we are taking the first value from the queue and then pop out the value, and then check for that element, then check for the element, its size, then check the element size, and then what have we done is that if character is equals to 1, then if the element is visited means that element is equals to 1 and visited and not visited, then what we gonna do is that we mark as visited, and then push the next value into queue, because we have to traverse all those values. Then what we're gonna do is return the count value as well as that. I have done like that. So in question that I have in answer I have attempted is that because in most of the cases you have given the adjacency list, because adjacency list take less space than adjacency matrix, and we can represent all these adjacency matrix in adjacency list. So we convert in adjacency matrix. Most of the times you have given, so it takes more time, more space. So it's all similar to as I explained. DFS solution, we visit the node, and all the edges that are going from the node, that the node value in the given graph, if it is not visited, then we call DFS, else we not call that. So this question is like that. Okay, next question, we will note more time in it. Rotten oranges. So if I remember correctly, in this question what we have done is that we have marked, it's a multi-source BFS, because we have marked all those oranges that are rotten. So those are rotten tomatoes, we have put it into the queue, and then what we have done is similar to the previous question. We traverse all these queues until the queue is empty, and then check if that so there is a condition that what we are going to do is that q represents the empty scroll, q represents the empty cell, 1 represents the fresh orange, and 2 represent the rotten orange. If we found while traversing from all these directions, we are going to traverse in 4 directions: up, down, and left and right. So we traverse one by one in all four direction using the condition like -1, comma 1 for previous row means upper row from the any point that we are solving, and +1, comma 0 for the below row, and similar to that is 1, comma minus 0, comma -1 is for the left, and 0, comma +1 for the right. So let's check the solution. Okay, so what we have done is that okay, I should add some comment here. No, I think I can't. I have to copy this solution code. Okay, so first we have taken the rows and columns because we have to find the length where we are traversing. So this is the condition for to find a row length. That's for column length. And we have initialized the queue. Initialize the counter, then put all these rotten tomatoes in queue, like these condition for row and column. If grid is 1, then what we are going this condition for what to store the counter means we have checking the there is what question is stating that return the minimum number of minutes that elapse until no cell has fresh orange. If this is impossible, return -1. For this return -1 because we have to check in last that all those oranges that are not rotten are converted into rotten. If not converted into rotten, then we have to return -1. So this can count all those oranges that are not rotten because we are already traversing all those cells in the matrix. Okay, it's good. Then we are checking the condition for the rotten oranges and pushing into the queue. So we have taken the we are taking in the queue their positions. Okay, so if the counter is equals to 0 means the oranges is already rotten, means there is no orange that is not rotten. So if that is not rotten, then the condition is already satisfied. Then we return 0. Then there is no minutes taken to be converted into rotten. So then if it is not, then we gonna proceed for next. Then we will check for the empty queue. Okay, cool. Then empty queue, if the queue is empty means there is no rotten tomato. If there is no rotten tomato, then we're gonna return -1 because if there is no rotten tomato, then we can't convert any orange into rotten, so it will take -1 minute. So that is already solved. and then we are going to start for the counting of time in minutes. First we are initialize the minute to the -1, and then what we are going to do is that find traverse in all four directions that can be possible to convert any orange that is not rotten into rotten. So like similar to that, if this is a rotten tomato given to us, then we traverse for all in all four directions, like right, left, up and down, and then there is no in its up and down, but it has in its right a tomato that is not rotten, and in down also it have the orange that is not rotten. So what we are going to do is that convert these oranges into rotten. Then for next traversal, similar to these all the in those two, because if we get if we get these into rotten, then we can put it into the queue, and then the next cells that we're gonna traverse is these two tomato oranges, and similar procedure again and again until we find all those tomatoes are oranges are converted into rotten tomato, or there is no condition to there is no chance that you can pass through the rotten to another. Like if you have any tomato that is not tomato, what I'm saying, orange that is not directly connected to any other rotten tomato, then it rotten orange, then this cannot be fulfilled. Okay, so this is the condition. What we have done is there that you can do by many ways, like you can make two other arrays, means two arrays with length 4, in which you can give the values for row, one for row, one for column. So like this is for the rows, first -1 1 0 0, and for the column 0 0 -1 1. This is for the up, down, left, right. So now we traverse for the queue. If the queue is not empty, so what we're gonna do that we traverse for the queue. Then let's take the size of the queue. We have to travel for all those rotten oranges that are present in the queue. So we take the size of queue, and we are traversing for the size and decreasing one by one size. So this is the condition for the traversing the conditions for all four directions. Like we have initialized the x and y, x for row, y for column, and taking the value from the q dot front, because we have initialized q for I and j. I and j means the indexes for any cell that have the rotten tomato, rotten orange. What the fuck? Okay, then we can pop out the values, because we have taken into the variable. Then loop, we and the loop for dx and dy. D and dxy means we are taking the name variable. Then for the dirs are those four values. So for I and ti, for the row index, we have taken the x means the values from the q, where we have found the rotten orange, and then we gonna traverse for the up value, down, right, left, similar to that for y. And we are also checking the condition for the what we call the outside the boundary. If you go outside the boundary, then this is not a solution. What are we looking for? We can't go outside, then it will be overflow. So we have checking the condition for I should be in greater than 0, and I should be less than row size, because we have to check only in the array, inside the array's value. Okay, this is similar to column. And also then, and this is the important condition for the grid. The grid is grid should be 1, because we are only converting the non-rotten oranges into rotten oranges. 0 for the empty space, because empty space we can't convert into rotten oranges. And if the orange is already rotten, then we don't have to do this. But if we have the non-rotten orange, then we are going to convert into rotten orange. Like this, for this cell we have converted into 2. 2 is representing that it is a rotten orange. And what are we going to do as what we have done is here that we have decreased the value of count. Why we have decreased the value of the count? Because we have taken all the non-rotten tomatoes in the count here. Look at that. Okay, so then if we convert any non-rotten orange into non-rotten orange, which means rotten orange, then we have to decrease one counter. Okay, and in last we have to check the counter is equals to 0. Then we have converted all these non-rotten tomatoes in rotten tomatoes. Then the condition is satisfied. Then we are going to return the time. If we don't, then we have to return -1. Okay, so what we have done is that we push the value into Q for the next rotten tomato, rotten orange. I think I have to file a petition to change this orange to tomato. But then what we are going to do is that for the every iteration plus 1 minute, and this is the condition for the checking the non-rotten tomatoes. If it is equals to 0, then return minute, else return -1. Okay, it is also done. So I think I'm taking too many time to explain, maybe revising my codes. Okay, then I will do it quickly. All these flood fill, that's an easy question. It is similar to the question previously we have done. The rotten oranges, not a matter. You are given an image representing image, where image ij represent the pixel value of the image. You are also given the 3 integers sr, sc and color. Your task is to perform a flood fill on the orange image starting from the index sr. To perform a flood fill, begin with the starting pixel and change its color to color. Okay, perform the same process for each pixel that is directly adjacent. Okay, pixel that shares the side with a original pixel, either horizontally or vertical, and share the same color as the starting pixel. Keep repeating this process by checking neighboring pixel of the updated pixel and modifying their color if it matches the original color of the starting pixel. The process stops when there is no more adjacent pixel of the original color. Okay. Like what this question is stating that is that you have given the source SR means source row, source column, the row and column for the from the center of the image, the position stage, the red pixel, the all pixel connected by the parts of the same color. You have given a single point in the matrix, grid, or anything you want to call. Then you have given any color integer, that will be an integer, you have to convert into this color. So what this question is doing, that you are starting from any point like 1. This is the input, that this is the grid, this is the point, and this is the color. You have given the 101 and convert into them. Then what we are gonna do is similar to the previous question, that you're gonna go up, left, down, right in 4 direction. If you found similar to this point, the value of that value of all 4 direction similar to that point, then what we're gonna do is that you have to change the color of that element, and you are gonna do that for every value until you found the condition for stopping that means you have gone for these four direction. Here you can't convert into the color because it is 0, it is not similar to 1, similar as that. Then you have to convert 1 because this is similar to this one. So convert this 1 into color, anything integer value that color have in this. So convert that into color, and then this color, and also the point value to the color, and then push these all values into the queue. We are going to be a solution. Then we are going to do is that a similar condition for this you are going to convert this element into color, similar for that color, until you found the stopping condition. And then what we're going to return is that we are going to return the change grid that we have implemented all the changes in it. Let's check the solution. Okay, so this is the solution. This is the condition we have given, and the original, we have taken the original color, original color of the image. If we are checking the condition, if the original color is doesn't equals to color, if color is equals to equal color, means that the original color is already equal to the color that we are telling the compiler to do, then it is already in color state. Then we return the image directly, then we don't have to perform any action in it. If it is not similar, then we are gonna do a DFS. So here we have solved the DFS. You can take any DFS, but in this question we have taken the DFS. For DFS we have to do these 4 operations. You can do these operations like in previous question we have done for the using the for loop, because for loop is going for the only 4 steps. 4 steps means that will be in 0 1 time complexity, and similar to that is that then you don't have to so, but the DFS only take this timer. It will take the 0 n cross m complexity. Okay, so here we have apply the stochastic condition for the recursion. We have taken the row column size. We have checked the condition. This is the important condition. There are all the boundaries condition, and this is the main condition, that image shouldn't be equals to the original color. If it doesn't equals to original color, then we are gonna do is that we return. And then what we're gonna do is that image is equals to 1. Image is equals to not 1. The image is equals to color. We are converting the original color into the color that we are given. And then we are checking all these conditions for all these direction, up, down, left, right, similar to that. Okay, now we have to move. Fly me to the moon. Flood fill, I guess we have done that. Detect a cycle and electrical using PFS. Okay, course schedule. So they are total of num courses you have to take, labeled from 0 to num course -1. You are given an array prerequisites, from where prerequisites are index equals to AIBI, indicates that you must take course B first if you want to take course A. For example, the PS01 indicates that the question 0, you have to first take course 1. Return true if you can finish all courses, otherwise return false. Okay, that this question can be solved by topological sort, but I haven't studied that yet, so I will do it by using topological sort again. But now I have done using the BFS DFS, because here what we have to done is that you have to take course when the condition for this that course what we call applied, means satisfied. Okay, satisfied. Like if you have a course and you have to take course B for enrolling into course A, then what we are going to do is that you have to add course B in your in your array, and then you can add then course B. Okay, so this is the condition. But what we have to check is that we can't take all the we can take the courses, all the courses, whenever there is a cycle present in the graph. Look how we are getting to that in this condition, in this example, you have is 1 0 and 0 1. So one is this telling that you have to take course 1 to get course B. Okay, so we have to take course B. So, okay, we understand. Then this telling us that you have to take course 1 to enroll in course 0. Okay, but we have already seen that you have to take course 0 or 0 for enrolling in course 1. Then this condition is not satisfying any way impossible. So what we're gonna, so this condition is not true. So how we can detect that is if we found any cycle, that because we have getting the in this problem is there is a cycle present in the plus 1 connected to 0, 0 connected to 1. Okay, so that's how we can get the and that this is not okay. Okay, what we have done is that we have taken the vector, visited vector for all the nodes we have to convert num courses, number of courses. These we can visit, we can create it the visited vector, adjacent list vector. And then what we are gonna do is that put all the values from the what the prerequisite is, that matrix that are telling us to the course condition we have taken the for enrolling. Okay, so this is the course, this is the integer for prerequisites, for means that this course for getting into this course we have to take this. So we have iterating that the first position in the this prerequisite is the vector that for the taking course is that we have to take, and this is the prerequisite for the for this vector we are taking this all these courses, we are pushing all those courses for the prerequisite, means these courses we have to take this prerequisite. So we require the prerequisite, so we have put it all the courses in the this adjacent vector that are representing the prerequisites. Okay, so we have created the visiting vector here for the size num courses and initialize with 0. Okay, so for this vector we have initialized the visiting vector for the num courses, initialized with value 0, and here we have the path visited. So we are also taking the path for the visiting all the courses, that is similar to the visiting vector. Then what we have going to do is that run the loop for num courses and check for the visited array. If the value is already visited, then we don't have to perform any action. If it is not visited, then we are gonna call the TFS solver. Okay, so in the TFS what we have done here is that okay, we have converted the visited node into 1. Okay, that's a primary case, we have to done that, and also we have converted into visit path also into 1. Then we have run a loop for the node for the adjacent node. In this we have the prerequisite courses that are have to be taken before applying for any courses. That you have prerequisite courses that are connected to the prerequisites. So then we have we also check the condition for the visited array. If it doesn't visited, then if it doesn't visit it, then we are gonna visit it using DFS, similar to that process that we have to convert into 1 and 1. Okay, and if it comes with the value true, means there is no cycle, then we gonna return is true. And else if the path visited it okay, then we this condition when is that we have to traverse over the condition, and the path visited is path is means that all the nodes are visited, then we are going to return is true. Then this path is converted, then we are going to set path again to 0 and return false. And here if the path is then if we have found that the return then we have check all those condition, and we have checked all those condition, but there is no value that we have taken means said that it doesn't have the cycle, then we are gonna return is true false, because it is said that it has the value means cycle present in the solution. So this also returns the false. And after that all those condition, if it doesn't have the any cycle in it and traverse all those courses, then you are gonna return is true. That's a tricky question. This is a 0-1 BFS. What is that? Given an m-cross binary matrix matter, return the distance of the nearest 0 for each cell. The distance between two cells sharing a common edge is 1. What does that mean? M-cross and binary matrix return the distance of the nearest 0 from each cell. Okay. The distance between two cells sharing a common edge is 1. Okay, the distance between two, that this one edge is 1. Okay, so okay, got it. Like we have to tell that for all those cells that the distance return the distance of nearest 0 from each cell means that you have to tell for every cell the distance for next not next the 0, any 0. Look, in this example we already have 0 for that, then we are going to return this cell return the 0, this cell also written 0 0 0 and 1, but the 1 is not 0. So what we're gonna do is that we're gonna traverse in all 4 directions. We don't know where we can find the 0 in most smallest. For the smallest distance, nearest distance, we have to apply the BFS solution for all the questions in which you have the nearest, smallest, fastest. Then you are gonna do is that you gonna apply BFS solution. Okay, I understand. Then from this one, we travel for 0 1 1 1, and what we have find out that these direction, the value for nearest 0 cell is 1. Then we can take any value that the nearest 0 have. This can be this will be 1. Then this for 0 0 0 0. Okay, then this is like that. And this question is that this example, this 0 similar to 0 0 0 and 1. What are you going to do is that traverse in 4 direction. Then you check for the this near distance. It's 1, and it is 2 3, but it doesn't have any 1 2 and 3. This is 3 distance, this is also 3 distance, and what you have to do is to find the nearest one. You have find the nearest one is 1, and for this it's 0, and for this you have gone for this direction. You have found the one smallest, because you have found 1 2 3. It's 3 1 2 3. There is the smallest is 1, so you don't have to do again. For this you have to do is that you have to go up down in all 4 directions. Then you go first in up, then you go up in over 4 direction. You can go, then there will be 2 for all 4 direction. That nearest distance is 2. And for this one, then you go for left 1 and 0. It's also 2 1 0. It's also 2, and down there is no value. Then the smallest value is 2. Then you can take any value. This output is stating that 0 0 0 0 1 0 1 2 1. So how we gonna solve is that it's similar to the question that we have done. Is that what's the question is flood fill. Like you have taken the first position and go for all the. So in this question what you have done is that this is the size, and initialize the vector for the size, because we don't want to change in the given matrix, because we don't want to change anything in the given matrix, because this is given data. So we have to perform action in different storage. Okay, we have initialized the visiting vector, and the distance, nearest distance. This check for the visiting, that we have visited the node, and this contains the distance. So we have taken the q the pair of pair, because we are taking the value and the smallest value and the distance. We are comparing also the distance. Then we are taking the 4 values we have. So we are pushing the all those values that are 1. What we are doing here is that we are running a loop for row and column. If the matrix is equals to 0, If the matrix is 0, then what we're gonna, then the distance is then we push the value into Q. We are pushing the this is the indexes, means the cell index, and this is the value. Okay, so what we're gonna do, this is the visiting vector, that we have visited all the zeros. If we visit all the zeros, then what remains is that 1. So for the all the ones we are visiting, and then what we're gonna do is that we gonna convert into 0, because if the 1 is 0 for the visited, then it tells us that these are not visited, so we have to visit these conditions. So this is the condition for traversing in the all 4 direction. So we are checking for the empty Q, because Q has to be empty for the solution. So then we are emptying the Q 1 by 1. So for the we are taking the row. First we are taking the row by taking the value from the first pair of Q, first value of first pair of Q. Okay, then what we going to do is what we have found is that is the value of row, and then the column, and the steps. Steps means the distance. Step contains the distance of the 0 from any 1, and then we're gonna pop out the value, and this is the distance from any one, not anyone, from any cell to any next 0. That's the question. So we are gonna do is that run a loop for the 4, because we have only 4 directions, and these the value are del row, del column. This is left, right row, these are the, then this is the condition for checking the boundaries, that the n row is inside is greater than 0, less than column, greater than 0, less than row. This is the condition, and this the condition, like the visiting is equals to, has to be equal to 0, because if it's 1, then it is already visited, then you don't have to visit it, but it is 0, then you have to visit it. So if it doesn't visit it, then now we are going to visit it, because we are visited this position, and we have put it into the queue. Okay, that we have already put in the queue, and then this question is again find out the O's distance from the location of 1, 0, and put it into the distance. Put it into the distance. Yeah, these again and again, and then the steps are written into the distance 2D array. Okay. Surrounded region. Oh my god, this question taking too much time, but repeatedly this will take less time, so I'm gonna revise not everything but as much as possible, because revision is the key. Okay, so what we have here is surrounded regions. You are given an M cross N matrix. Okay, I know M cross N matrix containing letters 0 and X. Capture regions that are surrounded. Connect A cell is connected to adjacent cells horizontally and vertically. What this mean? What does this mean? A cell is connected to adjacent cells horizontally. Okay, means the cell is connected. Okay, region. To form a region, connect every 0. Okay, we have to form a region, and how we can form a region? You have to connect the 0. Okay, surround. The region is surrounded with X cells. If you can connect the region with X cells and move, and none of the region cells are on the edge of the board. Okay. 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 Region. Okay. The region cells are 0, and you don't have to be. Means you don't have to be 0. Don't have to be in the edges of the grid for forming a region. Means forming a surround, because you have to cover all the directions with axis. Like here, that you have the 0, then you can't convert into the surrounded by all axis. Then this is not true. Like this, you can convert this into 0. So in this condition, what we are going to do is that you return the 0. Okay, so you have to return the matrix. Then you have to take the matrix, create a matrix, and this is example like that. Okay, so in this question, I think a solution, what I did was I did is that yes, what I have done is that I have checked all the edges of the matrix. Means I'm gonna traverse for all the running the first row for the row, for the first row and the last row, one for the first column and the second column. Not the second column, no, for the last column. If we found any 0, then it can't be converted into X. But if you don't found any 0, then all the values inside the X is converted into X. Just like that. As simple as that. So okay, there is no any other. Look, I have done similar to that. This is the size of board. Return 0 if it doesn't have any X. Means the size is 0, and the M is the this is the row size, this is the column size. We are traversing for the n length. Okay, then the time complexity for this is n. We are checking only just the conditions. So what this condition state that if the this is the condition for the row size. So in this condition we are checking I means the we are traversing from the row, not the row. Here we have only 0 means the first for the first column, and m minus 1 means the last column. So okay, yes, for the column, and the I will tell you that this is for the all this row 1 2 3 4, and the column is this column and this column. So 1 2 3 4, except these middle rows, middle columns. So let's checking the if it have if it's 0, then what we're going to do is that traverse traverse for the BFS DFS. Like if we have 0 at this position and also at this position, then it is directly connected to 0, and we can't convert also that in the surrounded region. So we have to traverse up till until we found the X in all four directions, all four directions. Like 0, this have all axes in all directions, as simple as that. Okay, and then we check for this, then we have checked for this. Where is the DFS? What? Okay, oh okay, it's above. Okay, so this is for the last column for all these rows, and this is for the jth, this is for the all those columns, for the first and last column. And we are gonna do that is the DFS for the all four direction. If we found any 0 like that, this check for the conditions, and if we found non-zero, means it's not equals to 0, then return. And for the checking, we have return is that converted all those the zeros that we are gonna find into any symbol. You can convert into any symbol for the any 0. For that, because you have created any created the array. Then for the this for the condition for the all four directions, and then after that, because you have converted all those zeros into this this symbol, then convert back into the 0, because we need 0. So we are running the two loops for the n row and m column, and if it is board, it equals to 0. If board equals to 0, then we are going to do is that convert into x, because we have converted all these zeros into x. Like we have to do that all these all those x's should convert the 0 that are lying inside the region formed by any x, and any 0 that is not formed by surrounded by any x's, then this we have converted into the symbol, and then we convert into 0, and we have done that. So we have written the board, we have to done in the given board. Okay. I have wrote so much for this comments. So this question is number of enclaves. You are given an m cross m cross n matrix grid, where 0 represents a C cell and 1 represents a N cell. Oopsie. A move consists of walking from one land cell to another adjacent 4 directionally land cell, or walking off the boundary of the grid. Return the number of land cells in grid for which we cannot walk off the boundary. We can't off the boundary in any number of ways. Grid in any number of ways. Okay, okay. Hmm. Okay. So that's the grid we have given. We have to do is that consider walking from one land cell to. Okay, you have to uh, walk. You just have to walk. Like you are walking for me. Okay, okay. So this question is saying that you can't walk outside the boundaries of the cell, and the uh, walkable path is of one. When wherever you have the one on the cell, then you can walk onto it. Like you are walking in this one, and then you are walking, and if you found there is one, then you can walk off the island. It's like you are trapping inside the uh, island, not in the on the island. Yeah, similar to the absent island. And then if you have, like, you have the one that is connected, this is going outside the island. Okay, you are outside. Okay, then this does not count as the walkable path. Walkable system, you have to count the return the number of land cells in grid for which we cannot walk off the boundary of the grid in any way. Okay, so here we have three walkable paths, 1 2 3. Then you can return the three, but this also have one, but we can't walk on that because we go off the boundaries. So, and let's see the second example. Like this is directly connected, these are four directly connected to the outside, and we can't solve that. So for this question, we can then we can then that we can do this similar process that we have done for the previous question. Like if you found any zero or any one that are connected to that 0 1, then what you can done is that you can uh, tell that you can't walk onto that, and you just have to traverse all the. So what we're gonna do is that if you found any one on any its edges, then you can convert into 0, because 0 is not a walkable path. If you found any 0, and for the uh, process means the process traverse, like we have done the BFS, because you can't go anywhere, you have to travel in the 4 direction. This is 0 0, then you can travel, but for this you can travel and go there. Then all these four zeros are also converted into 0, and then if you gonna check for the any one values inside this grid, then you found 0. So let's check the solution. Here we have the size counter 0. This is for the checking. This is for the checking the column. Here we have checked the first all the columns that and here we check all the rows. Okay, and for the BFS function, what we have done is that check the condition for that outside the boundary, and what's the condition you have to be to return that grid is equals to 0. If grid equals to 0, then you don't have to be look for any path, and then you want to do is that convert that 0, convert that what 0, convert that grid into 0 you are visiting, because every time you visit any node on the edges, you have to convert into 0. Okay, and all 4 directions, and after that you will return all the count of 1 that are surrounded by all the zeros. Here what you have done is that if we found any 1 inside the 2D array grid, then return counter. Okay, simple. Whatever, these questions are difficult, too difficult, too hard. Word ladder. I have wrote down every single line for every single comment for every single line. Heck. Transformation sequence from the word. Okay, so what this question is that this question tell you that you have given the word initial word and the final word, begin word and end word, and you have given also the list for the word for traversal word. You have to convert this hit word given to words, return the number of words in the shortest transformation. You have to do is shortest transformation. So transformation means you have to do convert that begin word to end word, but there is conditions that you have to follow, that you only can replace only single. You can replace only single letter from any from the begin word, the word you have, and you are go through like that and changing only single character one by one, and try to find the path to the end word. If you doesn't found any way to convert that begin word into the end word, then you can return false, means 0. You can't convert into it. But for the condition you have converted, then you have written the shortest transformation path. Path means the distance. Okay, so and also it says that if you convert into one hit to code, means you are converting like this in example, hit to hot, then this count as 1. This all the arrows counts are 1, 2, 3, 4, and all the 5. This count as 2 when you starting 1, 2, 3, 4, 5. So these two counts are 2. Okay, so how we gonna proceed that? So what we remember correctly, then what I have done is that what you gonna do is that for hit, that this is the example you have taken the hit. For hit you have put it into the any queue like every for this hit, and then what you gonna do is that take every single character from the left, like HIT hit. Then you are gonna do is that traverse all the alphabets 1 to Z one by one, and check that you have the similar word that are formed after converting into from A to Z inside the word list. If you found any, then this will be the next word. This will be the next word, and then you can start from the word that you are formed, like you have HIT, and you are traversing H for an A to Z, but you don't have any value that can have AIT, BIT, bit, sit, dit, fit, it, pit, kuch, anything that you have yet, but it doesn't have any value that you get from the traversing from A to Z, the H character. Then what we're going to do is that come to the next letter, that is I. Then what you're going to do is that also traverse from the A to Z. Then if you if you're traversing A to Z, then what you gonna find is that you can find only one letter in that example, that HOT. Hot means you have found the value for I, that is HOHAT, hat, HBT, SCT, HDT, and then and last you have found the HOT. If you found the HOT, then your next next word is HOT. Then you have to check for the HOT again. Then HOT, again you start from the H, then for all the check the A to Z, and this goes on and on and on. Then you have to find, and this is all condition for the shortest. This is okay. So I have explained as much as I can. So in this question, look, we should look at the question like, and we have initialized the queue data structure to store the word and its step. Okay, that is written very simply, that you have initialized the queue that are storing the word, that this string is storing the word you have taken, and this is storing the queue. Okay, so what will be the word we are storing? That push the begin word in the queue. Begin word means the begin word. Begin word means the word we are getting in the starting. Give me a minute. All good. Okay, so we have pushed the value of begin word, and we have as I said that you have to show value 1. And then what we're going to do is unordered set. We have taken the set because we are gonna take the word list in the set, and we are gonna check for the conditions like that. Now what we have done is that we will erase the begin word, because we have taken all the begin word in the queue, then we don't have to be taken in the set. And then what we're going to do, that while means while the queue is empty, we have to travel until the queue is not empty. Take the first word from the queue. Right, take the first queue. We are taking the first word, starting word, queue dot front. That is the first word we have taken the first, and the second is the step, but we don't need a step. Then the steps, we have taken the steps, and then they pop out the value from the queue. Okay, if the word is equals to end word, then return the steps. If a word is already similar to the end word, then our question is complete. That what we have to done is that convert the begin word into the end word. This all then we have to return, and if it doesn't equals to end word, then we have to perform the actions. Then action will be we are gonna do is that we are traversing until the size of the word that was like this is hat. We have to traverse for all these three letter, means for three letter. What we're gonna do is that first we're gonna take that first character. In first iteration, we have gonna take is that the first character, and then we're gonna do is that traverse for A to Z, and change the character, change the character to the A to Z. And then check for the condition if it exists. The word we have converted is exist in the word set, means word list. We have given the word list, we have put it into the what you call that, set. We have put it in the set and check for the set. If we found the word equals to set, and if we found that word which is equals to, what we have done is that we have to find the word that is present in set, means the word that is already present in word list. We have to check with the and. Okay, if it doesn't equals to end, means if it doesn't equals to end, then we have to perform actions again. Then what we're gonna do is we will erase, because we don't need now that word that we didn't found in the set, then we don't need it. Then what we're gonna do is push the next word, push the word and the step +1. So what we have done is that we are gonna do is that push the next word into the queue, and step will be the 1 plus. And if the word and if okay, so this for the all these condition for the for loop, like here we have found the a, this is for check, this is checking for the all these values one by one for all the 26 changes we have performed in any word, and by one, like a, if in a in the example of HOT, we did it AIT BIT first for AIT. If it now not in the set, then what we're gonna do is we gonna erase it, then push the BIT. If it also isn't found, then we gonna do is CIT again, SDIT again, DIT, EIT, FIT again and again until we find. If we don't find, then what we're gonna do is that we will convert into original word. We have the original character. Okay, and this process continues for every character. We have already the size. Okay, and what's the condition? And for every, if we have don't if any way, if we don't have any connection to the next word, then this gonna be not be this we will not have any way to go to the end word, then it will return 0. So this is the solution. Okay, that's very difficult. And number this is word ladder, this similar that, but this is a difficult, and you have a different solution for that. Number of distinct, this is similar as that. Yeah, I know about this question. This question is that you have to traverse in all 8 direction. In we have in all the 4 questions, in the all questions we have traversed in all 4 directions, but it have to be traveled in all 8 directions. This question tells us that this is in all direction, and this is similar to that, or similar to that. Now we have here that we have to solve bipartite graph. Let's close all these. So Is graph bipartite? This is a undirected graph, okay, with n nodes, okay, where, okay, each node is numbered between 0 to n minus 1. You are given a 2D array. Got it? Where graph U is an array of nodes, that node U is adjacent to. More formally, for each V in graph there is an undirected edge between node U and node V. The graph has the following properties. There are no self edges. Okay. There are no parallel edges. There are no parallel edges. Graph U does not contain any duplicate value. Okay, the graph if V is in graph, then U is a graph V. The graph is unidirected. Okay, the graph may not be connected between. There may be two nodes U and V such that there is no path between them. A graph is bipartite if the nodes can be. Take a deep breath. I'm speaking continuously for half an hour. Not half an hour, 1.5 hours. Okay. Okay. A graph is bipartite if the nodes can be partitioned into two independent sets A and set B, such that every edge in the graph connects a node. Graph in set A and node in set B. Return true if and only if it is bipartite. Okay, so what this question is stating that Okay. This is a question. What it tells about that? We have to convert that array nodes into two sets. 0, 1, 2, 3, 0 to 2. We can participate the nodes into two sets. 0 to 2, 1 to 3. Oh, what the ruckus? What they're doing? I think I'm getting the background noise very high. What is this question? Am I stupid? What is this question telling me? You have written true or false. A graph is bipartite if the nodes can be partitioned. Nodes can be partitioned. Means what does mean that nodes are partitioned into two independent sets A and set B. Such that every edge in graph connects a node in that. Such that every edge in graph connects. Written true if and only if it is bipartite. What is the condition for partitioning? The graph has the following properties. There is no self edge, no parallel edge, undirected. Okay, a graph may not be connected, meaning there will be two nodes U and V, such that there is no path between them. Okay, very like connected graphs. This is connected, this is connected, this is connected, this is connected. It's connected to all three. This is connected to two, this is connected to these two, and we can't partition this graph. Why? Because there is no way to partition the nodes into two independent sets such that every edge connects a node. Okay, every edge connect a node in one and a node in other. So what does that tell me? That it is also connected to this is connected to this is connected to this. Then okay, for this example 0 1 3 2, this is connected to these two and this is not connected to 2, so we can form this is telling us that you can form the sets 0 2 and 1 3. How? What? 0 is connected to 3, 0 connected to 1, 2 connected to 3, and 2 connected to 1. We can partition the nodes into these two sets, 0 2 and 1 3, like that. What the heck? Discussion can help. Respect to 76 or 81 case test cases. This is straightforward problem, but the description is positively often. Yeah, I can feel that. If they had an image with disjoint sets, and especially if they had one with colorized groupings, it would be clear that the intent was. Too much info. Bipartite graph. What is bipartite graph? I have heard it before. I have heard of it before. A bipartite graph is a graph whose vertices can be divided into two independent sets, U and V, such that I have said it many times. Into two independent sets, U and V, such that every edge UV either connects a vertex from U to V or vertex from V to U. Okay. In any possible way, you have connected to those two. In simple words, a graph is said to be bipartite graph if we are able to color the graph using two colors. We are able to color the graph using two colors such that no adjacent node have the same color. I got it. Yeah. Yes. Easy. No solution. Don't need it. I will try by myself. Got it. That's so what we have here is that 0 1 3 2. Here we can say that you have to convert into you have to color, means color that you the connected to the connected from any connected vertex from any point, any vertex is shouldn't be the same color as the vertex itself. What I am telling is that 0 have color. If the 0 color has red, then you have two colors, red and green. If 0 has color red, then the color of 3 should be green, and because it is connected to the 0, and for the color 2 it's also 0, and for the color not 0 it's green, and for 1 it also 0, not 0 green, and we go for the 3, and then we check for similar to this, like this is the green color. If we check for the 0, it's a red color. Condition satisfied. Both have different color. But for the 2 also have the similar color as 0, because not 0 is similar color to 3, because 2 is green and 3 is also green, because we have first check for the 0 value. All these three have the similar graph, but this is not the condition for the bipartite graph. Then this is false condition. Okay. So okay, as this, like in this example 0 1 3 4, this is connected to this current green, red, green, green. Then come to this check green, not colored. Then you convert to its opposite, red, and come to this 0. You check for previous, what is green, condition satisfied. Go up, check for this. This is for if you convert into that, for it will be converted into green, and it is red from this, and it is satisfied. If you check for this, all these conditions satisfied, then you can convert it into bipartite, because the two sets represent 0 and 2 have the similar color, like these two have the red color and 1 and 3 have the similar color, that is green. Got it? Okay, so I have to type with that. First I have to write the in my notebook what we 3 2 bipartite graph is that the similar the line. Okay, though then this is false. Red, green, red, green. I just have confusion in how we are gonna travel from the edges. Oh, and the vertices. You have given the graph. It's a 2D array. How we have given the values? You have given the 2D array graph u in array knows that u is the adjacent to our family. The v is graph u. There is direct edge between u and v. The graph is the following properties. Graph u does not contain u. Graph u does not contain duplicate values. V Leetcoding 72. First thing I can do is that convert the graph into the 2D array into adjacent list, and contains the list the value the list contains the value that where the edges are directing to and from the any vertex the edges are directing to all these edges, not the edges, all the vertex, and through we can check one by one all the vector int adjacent edge list li, which can be of size do have to specify the size of that. I can do that. And graph what graph type size, and adjacent the size will be n. Okay, then run for loop for will be 0 I less than what we have. Also take the size of row of column graph dot size but 0. Plus j plus 0 j less than j plus, and what we're gonna do is that for the edge list adjacent list for every vertex, we're gonna store the value of not like that. Actually I dot push back the value of graph, which value graph graph of I comma z. Yes, I think that will be good. Then we have put it in the adjacency list. Then we gonna we have to traverse in all the direction. So what we should do is that like if we draw the examples, if we get the example, if I'm drawing correctly, red green red green red green red green 1 2 3 4 5 6 like if you have no cycle in the graph, if you don't have any cycle in the graph, then there is no problem that this will be a bidirected graph in any way possible. You can convert that into 0 red green anyway. If you have like this 0 and these edges a b c d e f g h anyway, but if you have this cycle in the graph, then there will be a problem. And the problem is that if I'm thinking correctly that if you have no circle means circle means what does we call that? Cycle. Cycle means cycle, and the cycle length is odd. Odd means it's of length 3, 5, 7. Then there is a problem. Then there is a problem that we can have one value that is not similar to or the bipartite condition. Bipartite condition that both the vertices have are directly connected with vertices have to be of different colors. But in this condition, there is a condition that there is a possibility that they have similar color. Then this is not a bipartite. So we have to check only for the cycles in the graph. Wow. If the size of the so how we can find out the size of the cycle? And the position where the cycle starts. Or we just go like that, like traversing all the possible vertex that are connected and changing the color of that vertices. If we do that, it is possible to do that. Let's see. Like should we go with the depth first search or the breadth first search? Let's go with the breadth first and do it. So what we have gonna store is here is that and you also have to be connected with the we are taking care to show the edge and also the color, I guess. So let's put the value q dot push edge li HLI starting value of HLI don't approach. Okay, this is the intuition. I'm confusing how when we let's take a look at that. Like in this example, yeah, like these colors are different. You can take that, you can do that, you can change it with different color. Do that, you can. Then these have the 0 1 2 3 4 5 6 in the cycle, that is odd. Then this will be good, means perfect. And if this has the 5 and this contains the 1, then 1 anomaly, a bypassed. Okay, intuition. Can be colored using two colors such that no adjacent node have the same color. Any linear graph with no cycle is always a bipartite graph. Yeah, we know that. With a cycle, any graph with an even cycle length can also be bipartite graph. So any length with an odd cycle length can be the bipartite graph. Okay. Yes. That's how we know that. Okay. We can follow either of the traversal technique. Okay. Yes. In this article, we have also DFS traversal. Okay. DFS is a traversal technique which goes in depth. Okay, we know that DFS. Check for connected component in the graph. Connected. Okay. We are checking for all the connected graphs. We can check connected. If it, yes, we will check for the. As follows. The DFS traversal, we need to start node and a visited array, but in this case, instead of a visited array, we will take a color array where all the nodes are initialized to -1, indicating they are not colored yet. Okay. In the DFS function call, make sure to pass the value of the assigned color and assign the value. Same. In the DFS function call, make sure to pass the value of the assigned color and assign the same color in the color array. We will try to color with 0 and 1, but you can choose. And yeah. In DFS traversal, we travel in depth to all its uncolored neighbor using the adjacency list. For every uncovered node, initialize it with the opposite color to that of current node. If at any moment we get an additional node from the adjacency list which is already colored and has the same color as the current node, okay, we can say it not possible to color. It cannot be bipartite. Thereby return false, indicating that a given graph is not a bipartite graph. Yeah. I know that. So let's take a look at that. We have given this is the connected graph. Okay, we are checking for all the condition, all the vertices in the graph. Yeah, if graph color is not equals to -1, then we are calling DFS. I know this is the like this is the INT color. This is a array for, oh, okay, this is a visited matrix, visited array for color. Add edge vector int h1 into u push back v push back u. Okay, okay, this is a agency list. Okay, okay, so this agency list contains that for the value for you are pushing the value all the connected v's on the for the v connected u's, because you have undirected graph, that there will be condition for the checking the both dfs and the node color vector in the traverse adjacent nodes. Okay, here we are traversing the adjacent node, we are getting the color node and the visited matrix and the adjacency list. So what we have, what we are doing is here is that for loop, we are taking for loop traverse adjacent if uncolored, if it is uncolored, like we have adjacent in matrix the all the nodes that we are going to be colored, then if the node is if it is uncolored, then what we're going to do that we're going to call dfs and tell that it is uncolored, int node and int colon. What is that? What? Okay, means you are that if it's colored for integer color, if it is 1, then return 0 for the color adjacent, false return if previously colored and have the same color. What the? Okay, I think this is for today. I'll end the stream and we will continue. I have to learn about topological sort, watch some videos. Then I think I can solve these questions. I'm thinking, should I watch or learn in on stream or off stream? I think on stream is better, but you can't hear me. I think. Okay, thanks so much.